Let's get together to co-create a breakthrough for freedom of energy, sustenance, healing, and regeneration of the human vessel. Welcome to FESIG, the Free Energy Special Interest Group, where science meets spirituality in the quest for truth and knowledge to free humanity and transform this planet into a paradise.
Hi everyone, welcome back to FESIG's 88th meeting. This is the second session. We've just finished the first session. We have a superb presentation by Alosha Linov, which is about his Whitelarium project, which is amazing. You must watch that. I will process it publish into YouTube, into our channel soon. So a couple of weeks time. So catch up with it if you missed this meeting. Anyway, today's the can I have the PowerPoint presentation?
Oh yes.
Today is the 7th. No, sorry. Oh gosh, the 5th of May. 7th of April was last meeting. So welcome to FESIG, the Free Energy Special Interest Group. We have with us my FESIG brothers, Dr. Frez-Frezel, co-chairing with me. If James is here, he will be co-chairing as well. And so is Pontus. Pontus Hepster is the head of our R&D team, and Dr. Frez-Frezel is our chairperson for the R&D meetings that we have every Monday. So we're doing good. Right, so today, the second session is, Pontus is going through the slides, so you know what we are very quickly, yeah. And do go to visit our YouTube channel to see all the recordings of all the meetings, okay? And if we go to the agenda, on just the next slide, yeah. Okay, so the first session speaker, that was Alosha Linov. His wife couldn't make it, so he spoke alone about integrating biogeometry and permaculture ecosystemic system design into their living bioshelter organism called Whitelarium home. And we've done that, we've done the Q&A, and we adjourned to this second session. Well, in between, we did an honorarium of a tribute to, a eulogy of a tribute to Mark McCandlish, who's a very special speaker at FESIG, whom I wanted to call back to continue with the interstellar subjects that we were doing with the Taygetian Pleiadians, Trugotia and Beelharder. Unfortunately, it's too late because he passed away on the 13th of April. It's just too late. He was still corresponding with me in January, and he died of unknown causes, unfortunately. And one of our R&D members told us that after he died, he had his house ransacked, and they took away his papers, his drawings, his artwork, and everything. It's really sad. It really sounds suspicious. Well, you know what I'm saying. Now, this is the second session where we have American scientists, Dr. Harvey Charles Kaplan, who has filed more than 50 preliminary patents to date. We'll talk about making electricity in nuclear power plants safer, removing the radioactive contamination from water, and his transparent aluminum inventions. So once we finish the R&D, the Q&A, no R&D, we'll hurry. The meeting will then adjourn to the 89th FESIG meeting on the 2nd of June. So pen in your diary. And that is going to be another special meeting on the 2nd of June, because we have a very special speaker as well, talking about futuristic science, talking about ET technologies, talking about energetic universe and the language of energy. And the second speaker is to be announced as well. And I can't disclose who the speaker is because we've been sabotaged sometimes, you know. Okay, thank you. Thanks, Pontus, for showing the PowerPoint presentation. Right, you can write to me, crystal@truevisionpeace.com, right? So, okay, now I'm going to introduce our inventor extraordinaire, Dr. Harvey Charles Kaplan, PhD, CEO, Director of Research at KH Technologies Incorporated, Chicago. He graduated with chemistry, physics, and biology at Howard University, MD degree from Medical College of Virginia, and did a residency in diagnostic radiology at the Mayo Clinic. Is a fellowship in nuclear medicine and nuclear magnetic resonance at Rush Medical Center in Chicago, where he served as an adjunct attending physician. Co-founder, Howard Committee on American Foreign Policy. He is a retired nuclear physician with extensive knowledge of chemistry, optics, electrical, mechanical, and nuclear engineering. He has filed over 50 patent applications on over 100 inventions. 3 more of his invention proposals were accepted as entries in the NASA Tech Brief's Create the Future Design Contest. You can access all of his entries by searching Harvey Kaplan Create the Future Design Contest. Okay, and all this is all linked up in our website on the announcements of the speakers. All the links are there, so you can find them there. Okay, so you don't have to keep asking during the session, the proceeding, how to get in touch with the speaker. Okay, so he designed and built surface coils for Chicago's first magnetic resonance imaging scanner, developed and later filed patents on revolutionary new designs of CT, MRI, and nuclear imaging cameras and scanners, experimented in stereoscopic nuclear medical image acquisition and projection. He has devised a means of removing the radioactive contamination from the 100 million tons of tritium contaminated water the Japanese are currently preparing to dump into the Pacific Ocean at Fukushima. Right, so, right, most of his inventions revolve around making electricity and nuclear power plants safer. Now, over to you, Harvey. Take over the microphone, please, to do your presentation.
Can you hear me, Crystal?
Yes, you can.
Wonderful. Greetings, FESIG group. I am a retired hippie scientist who's had a number of abuses as a result of standing up against various aspects of the nuclear power industry as a stupid way to boil water. They have had 3 major accidents that we're aware of, but the issue is a lot bigger than most people realize. If you look at this diagram, can you make this full screen, Crystal?
No.
You can't. Okay. This right here is the entire firepower of World War II. And this is the radioactive material in to make the point that we have an unperceived huge amount of nuclear waste on the planet that has to leave or be processed into power. I have invented with Nikola Tesla a matter-antimatter reactor that will eat the radioactive waste for breakfast that comes out of a spill down or a meltdown from a Fukushima or a Chernobyl or 3 Mile Island-like accident. Can you project any of my slides, Pontus, at this time?
Yeah, I can.
This is a design for an alternative, not optimal, but satisfactory emergency containment for nuclear power waste that is a steel frame that's anchored in a underground trench concrete foundation. The steel frame has curtains to close the gas leak and it is pumped by 16 synchronously rotating fans, which you can see from the top view, I'm sorry, from the bottom view, as the little circles at the base of the triangles, and the curtains are seen at the outside edge of the bottom view. And inside this lot of nuclear plants that are sitting brilliantly on earthquake faults that are at risk of earthquake, that could potentially, if not protected by a device such as this, have a Fukushima-like meltdown if they do not advance the shutdown of all of these things and replacement with alternative means. This alternative dome is one that could be easily built with conventional technology. We move on to the alternate dome 2. If you could advance Pontus to the other diagram that is a little slicker. Here's a diagram of the foundation. It's like a concrete lined moat, and on the left you can see the plan drawing. The walls are separated by 18 feet, and they're 28 feet deep trenches. So what you're looking at is an inverted cake pan of sorts that contains 16 inches of reinforced concrete in each wall and in the base. And it is plastic lined to contain 32 million gallons of radioactive water if it needs to. On a transparent aluminum vertical tube that contains a turbine, a drive shaft, and a DC series homopolar generator and an AC generator. The lengthwise sections of the 16 sections in this 256 diameter foundation contain 14-foot diameter, 1/8 inch thick, 105-foot long transparent aluminum tubes wrapped in 36 miles of superconducting foil to create a synchrotron that will take the radioactive air that is pumped in from the 16 fans on top of these shafts from under the dome into the matter-antimatter reactors, which are located almost invisibly on this. You can see the top one with inside the circle at the 12 o'clock position is one of the matter-antimatter reactors. And in the 6 o'clock position, you can see an underground escape path to an auxiliary control building that has to be built that will allow the reactor underneath these domes. These circumferential moats are mounted around selected reactors, but people working inside the fission reactor can escape in an underground tunnel that is pressurized greater than the under the dome pressure, so that they will not receive any of the radiation that is escaping and being captured by the fans and fed into the matter-antimatter reactor. In the upper right-hand corner, you can see a cross-section of the foundation where you see it's 28 feet deep and 18 feet wide, and it's set in asphalt. We pre-excavate the trench around the reactor with a robotically controlled excavator. It requires only 2 people to control each excavator, and that is another design that is in the patent pending realm. If you look at the bottom of the right circle, you can see a plan drawing on the side, and you can see my phone is annoying but not necessary. Give me a second. At the bottom, you see a plan drawing where you can see the 2 dips where the foundation dips 28 feet, and that gives you a relative view of the depth of the foundation compared to the diameter of the foundation. And the transparent aluminum dome, or the dome you just saw, fits on the outside of this trench subway. The trench subway is so called because you can walk in it, except it has these horizontal solenoid tubes that are part of the synchrotron with the 35 miles of superconducting foil that generates a 1/4 Tesla field in the synchrotron to accelerate pressurized radioactive particles at 18 atmospheres compression into the 3 matter-antimatter reactors. Could you advance to the next slide, Pontus? This is a prototype of a matter-antimatter reactor. It's astonishingly simple. There is something like a bathtub-shaped size containment that surrounds a golf ball-size radioactive source, uranium, thorium, or plutonium. And the trick that proves the theory that was channeled through Tesla, and that is part of my nuclear medicine training, is that if you charge a radioactive material to a sufficiently high positive voltage, it emits alpha particles. It also emits protons and positrons. Now, an electron has, by Einstein's equal MC square formula, a mass energy coefficient of 511,000 electron volts, the same as a positron, but opposite antimatter versus matter. When this little sphere is charged sufficiently positive and it's emitting positrons, those positrons, as soon as they hit air in the cylinder, will create an annihilation reaction in which two simultaneously opposed direction 511K photons will go flying out at the speed of light through this bathtub-sized cylindrical containment to be detected by two gamma cameras that are hooked with an electronic detector to detect simultaneity. When this is done, and this experiment has not been done yet because I couldn't get a hold of a golf ball size piece of radioactive material in Chicago, when this is finally done and we charge that little sphere sufficiently, it will result in these 511K photons being detected simultaneously en masse. There'll be billions of them. And when they hit the gamma camera, they produce a little flash of light that is detected by a geometric grid of photomultiplier tubes that turn the path and the source of the electrons to a focal point, which is that sphere. And this proof is sufficient to show that you can produce antimatter with high voltages. Others have attempted to do this with Van de Graaff generators that only went to 550,000 electron volts, and therefore they saw no positrons. Unless you hit the mass energy coefficient of an electron and a positron gathered together, you will not see them split, and you will not see the positrons creating this annihilation reaction. And the uniqueness of this experiment compared to that one is that I plan to put 1,000,000 volts on that sphere. This is the basis of the matter-antimatter reactor that neutralizes the radioactive gases under the dome, those 3 matter-antimatter reactors, which we will see in a moment. Could we see the next slide, Pontus? This is a diagram of the matter-antimatter reactor. It looks real simple, doesn't it?
Mm-hmm.
It is a summary diagram. These things that look like coffee cans on the left, a larger coffee can around 10 o'clock in the diagram, and in the middle of the diagram, a smaller one, actually represent 64 synchronously rotating homopolar disks, which are on the 16 vertical drive shafts in those 16 circles that are vertically at the vertices of the hexa-decagonal foundation. And these transparent aluminum universal drive shafts are hollow pieces of transparent aluminum pipe that are made by folding a 1/8 inch transparent aluminum sheet into a pipe. Those 16 pipes, 28 feet in length each, are driven by steam turbines to 1,200 or 1,500 RPM, depending on whether or not we're dealing with a 60 cycle or a 50 cycle system. When spinning at that rate, the AC superconducting generators that are also located at the base of these 28 vertical synchronously rotating drive shafts generate 52 billion watts of AC power. Only 8 of these units with 3 matter-antimatter reactors each are necessary to power North America. To get the radioactive air into the plasma reactor, which is if you look at the pitchfork, the thing that's dark ink that has 2 circles, those circles are each 1 feet in diameter, and they house 24-pound hemispheres back to back to create 2 24-pound spheres, one in the top reactor, which is the plasma reactor, and one in the bottom reactor, which is the boiling water reactor. That water is boiling. Are you sitting down, everybody? It's boiling at 1,460 degrees centigrade. And it can do that because transparent aluminum has a 4,500 degree centigrade melting point. So what's the pressure? You know that at atmospheric pressure, water boils at 212. What's the pressure if it's boiling at 1,460 degrees centigrade? It's 18 atmospheres or 362 pounds per square inch. And that water comes out of the boiling reactor and powers the 16 steam turbines that power the 16 pod shafts, transparent aluminum universal pod shafts, drive shafts that power the 16 AC generators that are hooked in series to produce 52 gigawatts and power the 16 4-disc duranium homopolar generators generate 368 watts of DC power that gets fed into those wires to those 2 spheres at 1.022 million electron volts. So around the upper sphere, there is this plasma, and around the lower sphere, they're combining to form steam. There are 2 electromagnets shown in this design, and those are the 36.5 miles of superconducting wire that wrap around the synchrotron. I've shown it only around 2 tubes rather than 16 tubes. I've shown you only 2 cans representing the homopolar generators rather than 64 discs. But if you look on the other diagrams, we can convert it. Last, there is one thing missing from this diagram that is very critical. The plasma reactor gets its dirty air from the left of the diagram, and it enters a ball valve that isn't illustrated in this picture. That is a 3-inch diameter transparent aluminum spherical ball valve, identical to the Starr-Edwards heart valve that is in many people as a result of failure of the mitral or aortic valve. I was gifted this invention because at age 16, I watched Dr. Norman Thompson put a Starr-Edwards valve into the mitral valve of a woman who was on his operating table. I watched an entire open heart surgical removal and replacement of that valve, and that valve is critical for this invention. And I was given that assignment and given the opportunity to see that because something somewhere back in time knew that I would have to know about that ball valve to make this invention work. At least I think so. I mean, it's a theory that we're all rehearsing a script that's already been written. I subscribe to that theory. Pontus, could you show the next diagram, please?
Yeah, sure.
This is a shortcut diagram of a mechanism to filter the radioactive air from a Fukushima-like overpressurization through a heat exchanger. You can see the conventional reactor looks very much like the Indian Point reactor designed by GE that just was retired. And there is a 1.25-inch hole drilled through the reactor wall with a solenoid controlled valve to a countercurrent heat exchanger that is made by the intersection of flanged pipes that are screwed together. It's a simple to assemble heat exchanger, and the longer you make it and the colder the water you put in, the easier it condenses the radioactive steam to radioactive water, which go into these two filter canisters up in the 10, 11 o'clock range that also have solenoid control valves, and they are on a robotically controlled exchange mechanism where these filter canisters, when they become contaminated, can be removed by a robot, replaced by a fresh one. The superconducting wire around them is used to infinite lifespan. They have zero decay rate there. I'll show you hopefully the formula of transparent aluminum in a minute, but this is one method of trapping radioisotopes. A second method comes in a later slide. Can we advance to the next slide? This is a picture of synchronous harmonics. It is how I believe we should be transmitting electric power from central power stations, and how we should organize all of the electricity that is going on common lines. The lowest wavelength, in which all of the higher wavelengths are nested, could say be 60 cycle or 50 cycle. But any multiple of 3 times the lowest wavelength will nest. That is to say, it will cross the 0 points where the low frequency line crosses 0 points. And those lower frequency subharmonics of the 60 cycle, or higher harmonics of the 60 cycle, can be amplitude modulated without altering the 0 crossing. We could, if we decide to do it, transmit all of our meter usage signals, not by microwave to cause cancers in babies who have these RF meters on their houses. We could send it back through the power line as synchronous harmonic signals that could also carry internet, television, radio, refreshment for your cell phone, all available by just plugging your device into the wall socket, where these waves can be sent as carrier waves all the way from the power station. Now, some of us are going to come off the central grid, and this can be incorporated through a transceiver of information so that they would also benefit by this carrier current method. But a large number of places are going to depend on central power, and there is competition. Are we going to make it solar, or are we going to make it wind? But it isn't just that solar, it suffers from the wind not always shining, the sun not always shining, or the wind suffering from the wind not always blowing. These particular sources of electric power are finite. They decay and have to be replaced. There will be junkyards filled with windmill parts. As Dr. Kaplan is by name, that is a truth. And solar panels have a maximum lifetime of about 20 years, at which time they're going to have to be replaced. So why invest them in the first place when you can do all of this power with 8 prefabricable units that can be retrofitted over 8 vulnerable nuclear power plants that will also, in the boot, provide safety from impacting cruise missiles or airplanes or bombs or terrorists or tsunamis. Had these domes been up in Fukushima, we could have potentially survived the tsunami, and the lights wouldn't have even blinked if they melted down, because the matter-antimatter reactors that are driving these disk generators that are producing this potentially carrier wave signal that is coming out of the selected protected nuclear power plants covered by the matter-antimatter reactor transparent aluminum safety dome could potentially provide us with sources of power from nuclear that are far more efficient than anyone knows. These matter-antimatter reactors are 72,000 times more efficient than nuclear power. That is to say, 1 gram of uranium will go 72,000 times farther to produce a kilowatt of electricity. And one of these units will produce produces equivalent of 72,000 grams from conventional fission reactors, and it produces 1/1,000,000th the waste. The waste from this matter-antimatter reactor is lead-206, lead-207, or lead-208, depending on whether you start with thorium-232, uranium-239, uranium-235 or 238, or plutonium-239. The only waste is lead, helium. 18 pounds of helium comes out of 15 months of use, and 2 pounds of radium that can be trapped easily in a radium gravity trap. So this is a mechanism used on other planets that was channeled me by Tesla and his group. This synchronous harmonics signal here is a revision of the entire cell phone industry, because they're using pulse width modulation. This is amplitude modulation on a single synchronous wave. And as such, it does not cross the chakra frequencies as the pulse width modulation and pulse position modulation of 5G does. And it does not cause the immune deficiency that comes from 5G, which most certainly is involved in some aspects of COVID. This is just a meditation slide, and it's something that I put on to reflect peace. In the center, there's friendliness. It's surrounded by supportive, I can't even read it well. Let me see if I can get to the original copy real quick.
I can
Well, there you go. That's a help.
Yeah.
This has always been a sacred object to me, and it's why the dome ended up 16-sided, because it's a 16-sided geometry nesting a series of 8-sided and a 6-sided geometry. But Judaism is about love and tolerance and wisdom and compassion and supportiveness and faith. And the central thing that we have that also FESIG has is friendliness. We have to get into being humans again and respecting other humans as being equally infinite and amazing beings. Nobody has a monopoly on the Bill Gates genetics except for Bill Gates, and those genetics don't necessarily tune the right frequencies. He may have been involved in aberrant parenting and may have been involved with his money and drugs and the like, but Bill does not have the tolerance, wisdom, faith, love right now.
Well, it's not a question, but I think it's your internet. It's not your mic.
Could be.
Harvey,
Yes,
I
sir.
want to do a quick recap of what you've talked about. I've been taking notes, and this will kind of tie everything together. Your premise is a dome around a failing nuclear plant is the first step. In human technology, we usually don't try to fix it before it breaks. They try to fix it after it breaks, which complicates the process. If the domes that you're proposing are put in before the plant fails, it looks like it'd be much easier to install, but you have talked a little bit of how to do it after the fact. Am I?
After the fact, we're limited to inflatable domes that can be rapidly deployed with little exposure to personnel. It can be partly mechanized, but not a good situation. My original patent in 1990 was for inflatable domes, and I had a series of concentric inflatable domes with robotically changeable air filters between them. But you're correct. The situation is we have to install.
Okay, we're losing you again. I'll jump in. we've lost Harvey again.
It's using a process that can very easily be refueled. They can be refueled in one day.
Yeah. Okay. The next part of this on your premise is that the radioactive waste that's coming from the nuclear plants while they're operating and after they failed can be recycled using your matter-antimatter technology, correct?
This remains to be proof, but it's not necessary to recycle it. We can, because of the 72,000-fold improvement when you're using plutonium, thorium, or uranium, we can take nuclear warheads that have been taken off by the START talks and power planet Earth for 11 years.
Oh, okay.
All we have to do is take, that is truly the weapons into plowshares prediction of Isaiah 10.
Excellent. Okay. The next portion of what you're talking about is that we go into electrical generation directly under high pressure and spinning disks, but you're using the matter-antimatter and your aluminum, transparent aluminum shafts and devices to go at higher temperatures and higher voltage, correct?
Correctly correct.
Excellent. And I believe you were going to go on from that point to the production of this, either the chemical makeup of the aluminum, transparent aluminum, or how it's done, because I've never seen transparent aluminum. I've heard about it, but I haven't seen it.
You want to see the first published picture in human history of transparent aluminum alloy?
Yes, please.
Would that interest you?
Yes.
Let me see if I have it convenient here. Welcome to the 26th century.
Okay.
Aluminum, magnesium, simple cubic crystal. Melting temperature, 4,500 degrees centigrade. Hardness, Mohs hardness, 9.4.
Maybe I lost your mic. Okay.
Now, the two elements that make up transparent aluminum are simply the face-covered cubic structure of magnesium and the hexagonal close pack structure of aluminum, two different crystal structures of the metals. When they are melted at a little over 2,000 degrees centigrade, here's another picture of those two geometries. Hexagonal close pack structure like magnesium and the face-centered cubic structure like aluminum, when they are combined at high temperatures and with the right inert gases, produce a simple cubic equimolar crystal. In my research, there were 212 simple cubic equimolar crystals, many of which have never been used. I was a chemistry major at Harvard, and the cool thing about this, that is the elephant in the room, is that if you add to that nice cubic structure the right amount of lead, you get this structure, which is called neutronium. You remember the planet killer in with William Wyndham on Star Trek, where they couldn't penetrate it with their phasers because it was made with pure neutronium? I asked God, what is neutronium? And I got this image. And I got this image again in dreams. This is how lead, with the proper proportions, combines with transparent aluminum to produce a crystal that has 80 times the linear attenuation coefficient for gamma rays and cosmic rays as elemental lead. That means 1 millimeter of this equals 8 centimeters of lead. And it's light.
Wow. Excellent. Inert gases, well, for those that are watching, the reason we use inert gases with a lot of the chemical stuff is that it's non-reactive. And when we have oxygen, it wants to bind with everything and form oxides. So we go to other inert gas for refining. Yes.
That's very astute, but there's one more reason.
Go ahead.
What is transparent aluminum made of? I just told you. 2 elements. Aluminum and magnesium.
Yeah. They burn.
What do you think about heating magnesium up in room air?
No.
No. Here is yet another primary derivative of transparent aluminum. This is duranium. Same duranium that is mentioned in Star Trek. It is a room temperature superconductor. If you make disks out of this material and spin it, you can create a free energy generator, anti-gravity, and other things.
Interesting.
You will be interested to know that each of these alloys has derivatives. I'll just read the index here. Transparent aluminum is the precursor of postium and neutronium. Duranium is the precursor of jamesite, melicharite, melindicite, viogreen, emeraldite, iobite, and almalite, all crystals that have different properties. Almalite is like it sounds. It is brown and white, almond. Emerald light is green. Viogreen is violet green. Melicharite is red. Melindicite is, I don't remember melindicite, but jamesite is blue. And all of these crystals that are transparent can be made into lenses and lasers. We will have remarkable lasers that will be able to cut through titanium and weld other things. And the transparent aluminum I-beams that can be created by folding sheets of 1/8 inch transparent aluminum will be the building structures for future and buildings and spans and spacecraft. You can take a 1/8 inch thick sheet of transparent aluminum extruded and fold it into an I-shaped beam. That I-beam, if you take a 100-foot sheet by a 4-foot sheet of 1/8 inch transparent aluminum, it'll weigh 400 pounds because 1/8 inch thick transparent aluminum weighs a pound per square foot. If you fold that correctly lengthwise, it will support 100 metric tons of load. Not bad.
That's quite a laminated beam you got there.
It requires 3 bending machines that are uniquely designed to make all the bends. There are 12 bends to make the I-beam, and there are 2 boxes with a central connector, the way it is, that can be either symmetrical or asymmetrical. And in future buildings, in those hollow parts of the transparent aluminum I-beam, wires and cables and air conditioning and water pipes, hot and cold, will travel in the I-beams to where they need to be, and you won't have plumbers and everybody else because it's all going to be prefabricated. The I-beams will be X-ray welded, and the buildings can be assembled for a fraction of what present buildings are built. They'll be infinitely lighter. In fact, they'll be so light that if you seal it with a transparent aluminum outer wall and pump it full of hydrogen and oxygen, you could spark it and it will become a floating blimp. It'll become a vacuum if you spark the hydrogen and oxygen of a water-emptied building that is emptied by hydrolysis, because water contracts by 1636-fold when it's converted from gaseous hydrogen and oxygen to steam.
That was the other part that I didn't get an answer from you on, and we'll go back to your presentation. And one of the things that you were talking about was the collection of the radioactive air, which is basically water vapor and that type of stuff in it. but you had another way of condensing the water into a liquid form, and so you ended up with radioactive water, which takes up less space by 1,000-fold.
No,
So-
radioactive water does not take up less space by 1,000-fold. The removal of the radiation from the radioactive water allows the water, which is taking up most of the space, to escape, and the radiation is trapped in a magnet filter.
Okay.
If we go to the next slide, I think we can show you how that's done.
Okay, Pontus. The next one, please.
Thorium-232. It's one of 4 decay patterns of radiation that we see in nuclear physics. You will notice that each time an alpha particle comes off, the graph from the upper right shifts down either diagonally to the left or diagonally to the right. As each alpha particle comes off, you get a lower and lower atomic weight element down to lead-206 on the bottom. What I'm doing in this matter-antimatter reactor is charging these basketball spheres, size spheres of plutonium, thorium, or uranium to a voltage that causes alpha particles to collect on their outside, and they decay from thorium to actinium to rubidium down to radon, all the way down to lead. This is how the matter-antimatter reactor works. It generates both alpha particles, which cause the decay of the radioactive sphere, not in 4.5 million years, but in 15 months. The only thing that you need to accelerate the decay of uranium-235 and 238 from its 4.5 million year half-life is a huge positive voltage. And that huge positive voltage, in the case of the matter-antimatter reactor, is created by 64 duranium crystalline transparent aluminum derivative alloy homopolar disks spinning on transparent aluminum drive shafts driven by steam turbines, whose pressure is provided by the boilers of the 3 matter-antimatter reactors at 18.6 atmospheres and 1460 degrees centigrade. The entire operation, from the fans collecting the air to the plasma reactor and the boiling water, is all operating at 18 atmospheres. And that's what determines the 1460 degree boiling temperature of the boil. It's a simple chart. It's something that's well known, and it's common physics. If you have this pressure, that's where it boils. Next slide. This is the same kind of diagram from plutonium-239, our main bomb material. How much plutonium-239 is there? Do you remember those 2 diagrams I showed you at the beginning? 64 times that huge multiplicity of all the power, all the World War II power is in storage in used fuel rods that are a forever hazard if they are not decayed. What else can we do with them? I have an invention to launch them into solar orbit that involves a transparent aluminum tube just over a mile long and 3 feet in diameter that has 1,440 superconducting coils, duranium coils inside, that can be evacuated to launch a transparent aluminum capsule lined with neutronium that carries 8,000 pounds of radioactive waste at Mach 49 at the point it exits its electromagnetic launch point at the surface of the Earth. The military has already launched telephone poles into space. There's no theory problem here. It's just that I have designed a launcher that will launch either waste material into orbit or potentially fresh water and seeds and or inorganic non-compressible materials to Mars or the space station without rockets. It'll all be electrical. A matter-antimatter reactor will be set up to run them, or some other free energy generator could do it, but this launcher is obvious. A vacuum tube launcher. Why hasn't the military done it yet? I prayed to God to give me the solution. He did. Unfortunately, I haven't profited from it, but I'm hoping that I'll have enough money to live to be at least 90. In this world, there are a few people that are over 111 years old, and what is more valuable than living over 100 years? There are rumors that we used to live 900 years. I think it can be achieved. I think that we are facing so many pollutants and other things that attaining a clean lifestyle will be the challenge of this century, especially with vaccines. Next slide. This was the journal that I started in 1989 called the Journal of Environmental Radiology. You'll notice the poem I wrote in '89. The virus is spreading like a spot on the sun. The dead are the living in the future to come. While we clamor too slowly for the justice we seek, the virus is winning and it will take the weak. I'm pretty good intuitive, but this is not something I wanted to see happen. It's been 30 years of work to try to make it not happen. I had no idea that Gates and Fauci would be appointed to their almighty positions of infection czars, but I think that we have to be concerned. What happens if a nuclear accident contaminates a COVID population or a vaccinated population? What happens if Fukushima's cloud doesn't go over non-infected Japan, but goes over a part of the United States where 70% of the people have been vaccinated with a new vaccine that could mutate itself? We have to. You can see my girlfriend channeled the original diagram, which is in pen and ink under the outer transparent aluminum dome that was drawn by Dan Winter. The foundation was drawn by another friend with a cross pen and a ruler, and he didn't make a single mistake on the original drawing. So the foundation and Dan Winter's drawings show how Jenny's concept drawing from Tesla has these rotatable slam doors. They're like roller desks that roll up and close the dome on its 16 sides. Those are each 105 feet long, and the rollers, when they are rolled up, they're corrugated transparent aluminum, are about 14 inches in diameter in the underground foundation. You can see the two fans blowing air into a oval-shaped synchrotron. That's the 1,605-foot solenoids wrapped in 35 miles of superconducting foil that surround the reactor and contain the 18.6 atmosphere air pressure from compressing the radioactive air or just the regular air under the dome into the accelerated quarter Tesla synchrotron that feeds the radioactive particles into the 3-matter antimatter reactors. The diagram below to the right is identical to the more primitive diagram. It looks the same from the top. You can see those 16 small circles at the base of the triangles towards the edge of the circle are the vertical tubes, the TIFCA tubes, that transparent aluminum impeller drive fan, TIFCA tubes, that hold the transparent aluminum impellers. There are 32 blade fans at the top of each of those circles that compress the air into the synchrotron, and they're on the same transparent universal drive shafts that spin the DC and the AC generators and that are spun by the turbines who are pressurized by the boiling water of the 3 antimatter reactors. In the lower left-hand corner, you can see how the compressible material at the edges of the dome's doors can be locked in place by simply pulling a pin. So the doors roll up in the ribs, and a series of pins are either hydraulically or electromagnetically withdrawn to seal this hermetically. And I don't know how close it will be to a perfect seal, but if it's machined properly, that dome could be leak-proof. It could be the basis of a space station. In fact, it looks kind of like a space station. What if you remove the nuclear reactor and put this on Mars? Would it or would it not be an efficient way to generate electric power, have excellent air circulation, and provide a dome that would protect against meteors, against the low atmospheric pressure of Mars, that could also potentially be, if you didn't use the concrete in the foundation, a space station that spins to create gravity? I like having inventions that have more than one potential application.
Yes.
Yeah.
Do we have another?
I think
One question, Harvey, isn't aluminum toxic?
Not in this form. I showed you the crystal. It looks like table salt, and it's a perfect cubic crystal. It is not reactive at all. You can't cut it with acid. So the aluminum itself is very reactive. It has 3 electrons in its outer shell, and it combines with magnesium. Aluminum, I used to call aluminum 13 foil because its atomic number is 13. The first 2 electrons are in the S shell, the next 6 are in the P shell. That takes care of 8, and there are 5 more, 3 in the S and 3 in the outer P, but they are all combined with the magnesium. And when you get to this structure, it doesn't react with anything. It cannot even be cut with an oxyacetylene torch. It has to be cut with an X-ray laser. At least the ETs told me that, and I have no reason to disbelieve them. Can be cut with a diamond saw.
Are you
Right.
saying it's tougher than graphene? It's tougher than even
It's
diamond?
well, it's not quite as hard. No, toughness is one of these things that in engineering is thought of as tensile strength, compression strength, and hardness. Hardness is measured in Brinell hardness, Rayleigh hardness, and Mohs hardness. Mohs, M-O-H-S, is the simplest. It's a scale of 1 to 10, with talc being 1 and diamond being 10, and aluminum being around 5. Transparent aluminum is 9.4. It's very hard. It's almost as hard as diamond, which is 10. Because diamond is harder, it can be used to cut transparent aluminum. Because tungsten carbide is harder, it can be used to cut transparent aluminum. But because transparent aluminum is optically transparent, it can be cast into prisms and lenses and optics. And we have a new future of space telescopes that will come from these transparent aluminum lenses and their derivatives that will be able to see farther into space in gamma wavelengths than anything that we have done so far, including the Webb telescope. After the Webb telescope, there were much after that. What I was saying is that transparent aluminum refracts gamma rays. I know that because I took a wedge of it and I took technetium 99M and it bent the photons, and I calculated the refractory index of the metal of the alloy from a 3-inch scrap of transparent aluminum, which is the only thing that was ever produced in this alloy in physics back in 1989. That's long since been lost, but it can be reproduced. I know how it was made. The lenses are going to be the first thing that we manufacture. I have a company in California that's prepared to create the molds, which have to be out of a high temperature refractory alloy. Another company that has a piston compression inert gas furnace that will allow me to compress the materials that create all of these alloys by 2 pistons and create a disc or a lens. So the first task to moving this into existence is to get some money to go and rent access to that equipment and to buy the molds to generate a lens that demonstrates the theoretical optical possibilities of this, which will open the doors of money for everything else.
Right. I think we do have a lot of questions on chat. James, would you like to do the questions for Harvey? James,
We're not
you're
out of,
here, right?
we're not.
We have still some slides.
Oh, we're not finished yet. Okay, right. Gone then.
Not so many. So
Harvey, there's a lot of time wasted with the
vertical, the 16 vertical Todd shafts with the steam generator, the AC generator, and the DC generators, and the impeller. You can see that these vertical shafts, 16 of them connected in series, will produce a larger voltage and a larger power from the same steam output. They also have a compression valve closure that will allow under the fan for it to be sealed. And if you look to the left and to the right of the vertical 15-foot diameter TIFCA tube, you can see the edges of the 105-foot solenoids that are air sealed to the TIFCA tube, transparent aluminum impeller fan containment tube is what this is. And the things that are labeled on the right, you can see these horizontal lines just going up about a ½ inch to the right. Those are the edges of the 105-foot tubes that are wrapped with all that superconducting foil to create the room temperature superconducting synchrotron that is a 1/4 Tesla that takes radioactive particles and keeps them from adhering to any part of the apparatus, because they vortex in the magnetic field and they don't contaminate the apparatus as a result of that magnetic field being there. That magnetic field is used to carry the DC voltage from the homopolar disks from one to another to another to another to generate the whole 1.022 million electron volts that is needed. The series connection between the vertical TIFCA tubes homopolar generators, the series connector, is the solenoid tube that goes between one TIFCA tube and another. So it produces a series connected electromagnet that is the equivalent of a synchrotron. You hear that?
Yep.
Can we move to the next page? Oh, up top is this is a diagram of the turbine. A turbine is made of another exotic alloy, but it is an unusual turbine in that it is 16 steam jets. It isn't the turbines that you see in nuclear power plants with the huge number of vanes and the huge amount of expanding steam. This is much more concentrated. These 16 steam jets are made from an alloy called Nikola-Russellinium, which was named after Nikola Tesla and Walter Russell, both of whom had input into this invention. Next slide. That's another close-up of the steam generator. It's elegantly simple. And I originally was going to use Tesla turbines, but the guides told me no, this is a much more efficient way of turning the steam into power. The steam jetting out of these 16 jets spins the Todd's axle, which is that small circle in the center, at 1200 or 1500 RPM, depending on whether you want the generator to operate at 50 or 60 cycles. I think the next slide is the generator. No, that's a 8-blade rendering of the shape of the fan, which is similar to a jet engine fan, but it's slightly more efficient because at 3/8 of the distance of the blade from the tip to the center, the blade is angled at 30 degrees. This causes an angular displacement of the air as the 32-blade fans are spinning that increase the contact area of the compression impeller blade with the compressed air and thereby generate a larger pressure per rotational torque. Next slide. This is a diagram of part of a valve that is used to
Scott, you're so
Choose a
good. The ringing. Yeah. Go on then, Harvey.
I'm sorry.
We missed it from the beginning from this slide.
Yeah,
Okay.
because
This-
Scott rang the bell.
I'll-
Did you hear that?
I'll repeat. This is a diagram of an electromagnetically controlled triple knife valve that controls the steam pressure to the turbines from the boilers. There's another picture like this coming up next that is similar, that shows you the pistons. This one.
Yeah.
These three pistons are, if you look on the top, you see that triangular opening. These are triangular pistons that are moved in and out by electromagnets that have a linear feedback loop that knows how far the piston is based on the frequencies that it is tuning, RF frequencies that it's tuning in the superconducting coil of Arvinium alloy. This is another transparent aluminum alloy. Pistons move in and out over knife grooves to control the amount of steam that is going vertically down the center shaft of the center two triangles there. The upper picture is a side view that shows the triangular knife channel. The lower corner shows these triangular wound coils, and the coils have two functions. One is that they conduct steam into the reactor, and the other is that they electrically are connected to a circuit that precisely knows where the piston is and adjusts it in a negative feedback loop with an optical character reader that measures the rotation speed of the turbine.
Thank you.
Next. This is another picture of that decontamination apparatus. You can see the countercurrent heat exchanger approximately at 7 or 8 o'clock. The magnetically chelating transparent aluminum barrels could conceivably be made of polycarbonate if we have to rush, but the best form would be to line them with neutronium radiation resistant and making them of transparent aluminum and launch them into space, because they can be launched with this electromagnetic launcher and it will take out 8,000 pounds of radioactive waste per launch. You could get as many as 10 launches per day. 80,000 pounds of radiation. A device not drawn, but it is, I did send an abstract in one of these things. It is a method of evacuating a vertical mile or so long transparent aluminum 1/8 inch thick tube that is 3 or 4 feet in diameter. And the capsule is wrapped with superconducting electromagnets or fixed magnets, and it is accelerated electromagnetically by 1,440 100-turn duranium coils that surround the tube, either outside or inside the tube, depending on the manufacturer, to generate a vertical magnetic acceleration not different from the railgun that launched the Navy a telephone pole into orbit. This, however, designed additionally by vacuuming out the tube before you start acceleration, so that the accelerating capsule does not have to push atmospheric air out of the way. When it hits the apex, it hits a conical seal, and it carries that cone seal with it. The capsule itself has a cone on it, and it intersects with the seal cone while the tube is evacuated during the electromagnetic launch and it hits the surface with the mathematics I have calculated.
I only picked the pictures. Yeah.
Okay. I will send you by snail mail a copy of the entirety of this talk and the figures. You can publish it any way you want.
We can only publish the video here. Right. I think we got to go to Q&A now, Fres. I think Brian might have some questions. Our Brian. Is he here? No?
I don't know if he got it in.
He was here
Yes,
earlier.
Yeah, I know he was here. He jumps in and jumps out.
Yeah.
Is James here?
James is here. Hey, James, you want to do the Q&A from the chat?
Chats?
Sure.
Thanks, James. Show yourself, bro.
I just want to make sure. I don't see a bunch of random questions. So how far back does this go? What, since the beginning, I guess?
Harvey, let me introduce James. This is James Ring he's the ringleader of the Super Soldiers from supersoldiertalk.com. He, of course, he's with us all along from day one at FESIG. He's one of the ETs, right? Yeah, Conan.
All right. So we had, I guess one of the first questions is here. Well, I'd like to know is the actual cost. Do you have any ideas on how much it's going to cost to manufacture this? Because, you know, obviously, if it was inexpensive, they would be implementing all these systems already. So, and is there ways to bring the price down? And how fast can you think we can put this into the marketplace, the different transparent aluminums?
Well, depending on how much help I get, I've been carrying this burden since 1983, and it's a little difficult to carry all of the things I've been given. I am the custodian of this, but because of that, I have been under attack. I'm also politically active. I think with proper funding, we can have a piece of transparent aluminum by the end of summer, possibly a lens and a nuclear camera by August. How much money is that going to cost? Best guess, around $250,000.
Right. Okay. Can this technology prototype assist in clearing radioactive contamination, such as depleted uranium, from land and water bodies? What do you think about that?
In the sense that we can fracture soil and mix it with chelating materials that will grab the radioactive material from a slurry. There are a lot of slurries at Hanford. It's difficult to decontaminate the radiation in the fields, but we finally got me on full screen. That's great. It's difficult to decontaminate it, but I have a theory that if you hit a sufficient high positive voltage, that portable generators can be lowered into Chernobyl, and that the high positive voltage, we're talking million volts, almost lightning level voltages, could potentially be used with the right kind of robotic applicator to decontaminate radioactively contaminated soil. That's theory. I don't have proof.
Mm-hmm. Okay. What would happen if these sites are over fault lines and an earthquake happened? Could we just get them all off the planet?
In the New Testament, Christ once said that these stones of these buildings here, not one will be upon another when the end comes. And it also said, every plant that my Father has not planted will be lifted up.
All right.
I don't know the answer. It would be nice if we could just send them to another dimension. But I have a good answer for you. The neutronium radiation shield is going to be remarkably important to make radioactive areas humanly habitable. It also will make transgalactic space flight possible, because cosmic rays are really serious problems for getting out of the solar system.
Okay. So someone says here, can we get a document as shown by Harvey with the crystal structures and crystal names and any other info about those crystals, like melting temperatures and appropriate atmosphere in which to make them melt?
Well, I think I can post it on Leroy. That is from our R&D team member, James. We can post it on the R&D team group. Okay, thank you.
What we're going to need to do is work one alloy at a time. Before you can produce molybdenite, you have to produce transparent aluminum because it's a derivative. Before you can produce duranium or neutronium, you have to produce transparent aluminum. So the first thing that's going to come out is a simple aluminum magnesium crystal that can be formed in a compression mold in a furnace. I have the company to make the mold. I have the company to make the furnace. All I lack is financing to rent their $5 million furnace and to make the molds. And my best estimate is that to make a prototype lens and to put it onto a conical support for a nuclear medicine camera to create a new nuclear medicine camera, which I didn't mention, by the way. One of the first instruments to prove the optics of transparent aluminum alloys is going to be the Hallanger 1954 gamma camera without a collimator. Does anyone know what a collimator is on a nuclear camera? Anyone here? It's like a slab of lead with a gazillion parallel hexagonal holes.
Okay.
And if you place that on top of a thallium dope quartz crystal that is in front of a hexagonal array of photomultiplier tubes, when a photon comes off of a nuclear medicine injected patient who's been injected with a tracer isotope, if it goes through the holes of the collimator and hits the crystal, it produces a flash of light. But 95% of them are attenuated by the collimator, and it's only 5% efficient. If you replace it with a lens, it'll be 95% efficient, and you'll use 1/10 the dose of radiation to do the same image. It also will be precisely focused to a micron, and the images of nuclear medicine will get better than ever. I'm a nuclear physician. I'm board certified in nuclear radiology. I can say this with fact.
Thank you, Harvey. Can you comment about the actual patents? Is this technology been patented already? And do you have access to the intellectual material, or are you trying to you found a way to get around that?
According to Obama's rules, the first to file is the inventor if it comes to court. So technically, I own the inventions. They are only preliminary patents at this point. I have never been able to raise the money to have a utility patent. Even on transparent aluminum, something has always sabotaged me, but that's about to end. I have so many heartbeats left. It is tragic that this didn't happen 30 years ago. It could have, but I've been hit over the head by a pistol, hit by 2 cars, broken 3 vertebrae, both hips, been injected with innumerable psychiatric medications and forced in a 13-year prison sentence in a psychiatric rehab facility to live in an 8x8 room with my computer where I typed 50 patents on over 300 inventions.
We're so sorry to hear about that, Harvey. Well,
No, it'll make a movie someday. I'm sad that my life has turned out this way, but I'm not dead yet. And if you know a nice young woman who could stand being around a funny older guy, I certainly fit that last quote.
Harvey, have you made some prototypes at all these years with all your creative ideas and
I prototyped transparent aluminum as a wedge back in 1990. I tested it at University of Illinois with radioisotopes and a gamma camera, and I calculated the focal length of a transparent aluminum
Have you got
lens.
some photographs of those? Got real photographs of those?
I got into an argument with my landlord of 7 years who was an anti-Semite, and he brutally evicted me, put me in 3 hospitals, and stole all of my property and locked it in another city. I have the proof, but it will take a year or 3 to find, and I will have already produced another prototype before I have all of those things that I did in the past. I have it in my mind. I have the notes. I've lost 3 computers. I don't have the hard drives, but I have the notes, and I have typed copy of 40 or 50 patents secure to rescan. So the knowledge isn't lost. It's just the joy of life has been missing from the creativity that deserved a lot of joy.
Oh, we're so sorry to hear about what happened to you. Is there any other questions, James?
Yeah, sure, Harvey. What is the feasibility of actually using this technology to encase a entire city in a giant biodome? Do you think the price could be brought down to a way that's economical to use?
Biodome would be better served by airscape type inflatable domes. There are double polyvinyl chloride Kevlar reinforced double sheet domes that have embedded steel wires, and the inflatables can cover a whole city. To build it out of this alloy, the Emerald City of Oz is possible. One of the alloys is green and it gives off a green glow. Technically, you can build buildings with robots that are very large and very light, and they will in the future be detachable from Earth. They'll be built with anchors rather than concrete foundations, and when they decide to put them in orbit, they'll pump the air out of them, and the fact that the vacuum will take tanks into mid-air will make it possible to produce cities in the sky someday.
Okay, great. Thank you. Can you share your contact information or your website?
James, I always tell people not to ask for
know.
that because it's in the website. All the links, the speakers' links, how to contact them is from our website. Yeah, thank you.
I think that's better. I'm majorly handicapped with problems in the web and political problems with our fascist government right now. So I'm getting a message a minute on my email. Lots of it is going into spam and trash. However, if you mark it important, the email is doctorinvent, DOCTORINVENT at.
Can somebody type that on chat? Say that again, Harvey, please.
Well, he'll just have to put it. We'll put it in the title description there because just broke up again.
Yeah.
All right. Well, Crystal, you want to go ahead or?
I don't even have Harvey's email address, honestly.
I have it.
You have it. Oh, good. Cool. Yeah. Yeah. So Pontus, would you like to put that on chat if that's what Harvey wants people to write to him? Yeah. Okay. Thank you. All right. So is that all, James? Is there any other?
Well, somebody comment here. I bet they already do this on other planets.
Mm-hmm.
I think they use some kind of shielding technology in addition to this. So it's both of that. Because you probably have to do the shield inside and outside because you don't want stuff dropping out like biodomes, that is. But yeah, it could be great if they could build like a hyperloop inside of one of these things. Or
well, thanks, Pontus.
The hyperloop would be a very good project.
We're gonna let go there.
I heard.
Go ahead.
Sorry, go ahead. Who's that? Will? Is that you? Or Scott? I hear you. Is that Leroy? Anyway.
Connection is unstable.
Can't hear you.
Yeah.
Can you write in the chat instead?
Yeah, write in the chat and James will ask that question for you. Go on then. Okay.
Is anyone good at lip reading?
Okay.
Is anyone good at lip reading?
Okay, so the email address is doctorinvent@gmail.com.
Okay, so the email address is doctor.
All right, well, why are we getting feedback?
Can
Alright,
echo
why
back,
we get
James.
feedback?
I
We're
think
gonna have
this
to round
is
this up.
wasting
Here are
time.
two streams. There's one delayed and one on time.
Yeah, we're gonna have to wrap this one up.
Yeah, okay, thanks, Fres. Yeah, take over, Fres.
Basically, Harvey, thank you very much. We've just got a whole bunch of interference from all over. Either we've got solar flares coming in or we've got gremlins in the internet. Thank you so much for everything you presented today, Harvey.
I hope that the tape is usable. I think you should announce in the tape that many times where we broke off, we came back when I found out what was missing and filled in. So a lot of those gaps were filled in, and I think the tape is very valuable with what was disclosed.
Of course,
Yes.
and
Thank you.
we will have you back, Harvey, and we will try to make the complete
Yeah, you got plenty to
presentation.
share.
Yeah.
If I may,
Let's do a brainstorming later after the recording, okay? I think I'll go around the table. James, is there any last say you wanted to do before we close? You look like you're having a headache. So am I. Okay. Fresh, any last say?
No, we're good. It's a mess right now, so we'll do the best we can. Thank you
Okay,
so much.
good, cool. We'll do the best we can, Harvey. Thank you. You have put in a lot of effort here. We know, we understand, and thank you so much for bringing such futuristic technologies so advanced to our physics team here. Thank you very much indeed. Unfortunately, Brian's not here to ask questions because he's excited to see what you got here. Pontus, you got any last say before we close?
Oh, thank you very much. And Harvey, I will send you a mail.
Yeah, and thank you, Chris, for saying such great synergy here. Yeah, thank you. So there being no other business now, this 88th meeting will be adjourned to is adjourned to the next meeting, which is the 2nd of June, our 89th meeting. So pen that in your diary and come back, okay? And thank you very much. Namaste.